Day 9. It's got to be something interesting. Hi and welcome to another episode. What we've got here is the PiHut Advent Calendar. Let it glow. We're on to day 9. What's inside? More wires. I do like the wires. Oh, some wires and some rattly things. What are they? What is that? It says Azer on it. I'm going to guess it's a speaker of some sort, but I have no idea. It rattles a lot. Oh, it was doing. I think it's the pins rattling around. Right. Close that up, put that back in the box. Slide this across, making sure it's unplugged. Let's go across to the website. And what do we have? It Let It Glow Maker Advent Calendar Day number 9. Ice cold coding. It's a temperature thingy. It's a temperature sensor, isn't it? Let's have a look. It's day number 9. Let It Glow Maker Advent Calendar Day is another control component day, and it wouldn't be right if it's for us not to include a temperature sensor. Oh, that's what it is. Considering the cold snap you usually get at this time of the year, and how fun they are to play with. Here in the UK, we've had a couple of days of snow, which confused a lot of people for a couple of days, but now it's all melted away again. So doesn't look like we're having a white Christmas this year. It looks more like we're going to have a soggy one. Maybe even temperatures above 10 degrees Celsius, which just isn't normal for here. But oh well. Anyway, that's me being a Brit talking about the weather. The festive season is usually a chilly one, so we'll show you how to use this sensor to keep an eye on the winter temperatures whilst using our blinky components to give us visual indication of how hot or cold it is inside. The sensor in today's box is a little smarter than some others, as it can measure both temperature and humidity, and talks to our Pico in a different way using something called I2C. Don't worry, I'll explain it all. So the component itself is a DHT20/AHT20 temperature and humidity sensor. Okay. Right. Interesting. I've not actually seen one of these before. Bit obvious really, otherwise I don't know what it was. But anyway, today's activities, today we're going to learn how to use the temperature sensor using the readings in our code to print the information and drive the RGB LEDs. There's a lot to learn today, including some slightly more advanced stuff, including I2C, library installation, and dictionaries. So let's get cracking. Okay. What is an I2C? I2C, sometimes referred to as an IIC, stands for Integrated Circuit. I can see where it says I2C. A bit like Hitchhiker's Guide to the Galaxy. Sometimes that's referred to as H2G2. Anyway, it's a communication protocol which allows multiple I2C devices to communicate to the controller, like our Pico, passing data to it for us to use in our program. I2Cs require just 2 wires to communicate along the 3.5 volt and ground wires for our sensor, and has benefits over some other communication options, but we won't bore you with that right now, as it's not going to be relevant until you much further along on your maker journey. Oh, okay. You can't use just the old GPIO pin for an I2C either. You have to use the blue SDA or SCL pins, which you'll see in the Pico pin map. Okay, let's have a look at the map again. And I'll move it across. Very exciting on one of my many screens. Where's my cursor? Oh, there we go. Dun, dun, dun. Right, so the blue ones. Oh, so these. What did it say? Oh, lost it. The SDA or the SCLs. SDAs, SCLs. So it's the same pins, just they will be referred to as something else. It seems, anyway. Maybe not everything is a one, but okay. To use the IC, we also need to import it into our code, which will show you how in just 2 ticks. Construct the circuit. As always, make sure the Pico is disconnected from the USB cable when working with the circuit. Prepare the breadboard. We'll be using our LED ring with a temperature sensor, so keep that wired up the same as yesterday, and remove the slider potentiometer. Okay, so let's make sure the wires are the same. So very subtle way of doing this now, so we just pull these 3 wires and we pull the slider out. Right, that was easy enough. Fit the temperature sensor in another easy component today with just 4 pins to look up. Just be gentle with it. Just be gentle with it. It was in bold, that bit. Those little legs don't like to be forced. Okay, right. Then wire it up, working from left to right with the legs 1 to 4 as follows. Okay, so we're all the way over on this side. On the top board, we want the left leg to be in, where is it now? F. Can we figure it out? 3 from the left on there. So F, 3 from the left. So we want that to be, we can get to go in. What number is that? Number 27. So the left leg goes in F27 and the rest of them go in that. And obviously the grill bit of it, have that facing you as well. And it's quite easy to slide in. It was a bit fiddly at first, but then suddenly it fitted. Now we need to do the wiring. My screen's not quite deep enough to see everything in one go. So let's pick up a red wire. I've got one over here. I know we've been getting wires and wires and wires the past few days, but there's no point breaking them apart when we've still got access. Right, so anyway, J27, we want to go, which one's the left leg? Needs to go to physical pin number 36. This is the 3.3. So that's going to be 1, 2, 3, 4, 5. So on the bottom board, that's J5. Let's get a blue wire. Blue wire. Next pin along on the top board. That's that one. Just for reference, that's J26, and we want to go to, where do we want to go to? Blue, so 2 up. So that's physical pin 19, so that makes it easy for us because that's A19. It's easy when it's that way around. Let's get a dark colour one, so let's do the grey one. So the 3rd pin, that's J25, and that's going to, oh, 3rd pin is pin 18, so just the next one along there, so that's A18. And now we need a green one, which we have somewhere. There we go. So on the top board, J24, and that's going to, trying to get through all the different bits of the wires. I'm trying not to make too much of a rat nest about it. A20, no, yeah, A20. A20. Just double check. Yep. Your breadboard should look like this. Your sensor will be black. Okay, that's fair enough. Tip, we're using the SDA and the SCL pins in the GPIO 14 and 15, but if you look at the Pico pin map, you'll see that we could I've used many others such as GPIO 10 and GPIO 11, for example. The Pico has lots of I2C pins to choose from. Okay. Install the code library. Before we can use the sensor, we need to install the library. Until now, we've just used the libraries that are already part of the built-in to the MicroPython. Sometimes you'll want / need to use external libraries which require saving them on your Pico first. Then we can import them like we usually do at the start of a program. So we need to get the DHT20 library installation. We're going to use the excellent Pico-DHT20 library code created by GBHub user, I think that's FLRRTLTH. So Flirth maybe? Flirth, or is it Flirth? I don't know. We're not going to ask you to navigate to Scalable GitHub. Instead, we've copied the library code that you need and placed it below. Copy the long code below over to the Thonny in the usual way, but instead of running it, select File from the main menu and Save As. Then when a box appears asking where to save it, select Raspberry Pi Pico, call it dht20.py and select OK. Fair enough. Okay, so we need to copy, paste it. It told us to save. One thing had been useful to know, plug in your Pico, go off to the top here, press stop, click File and click Save As. Now you can select Raspberry Pi Pico, and then we need to name it correctly, which was what? This. So I'm going to cheat and cut and paste this bit as well. To make sure it's correct, press Ctrl V and then click OK, and there it zapped it across to the Pico. I'm not going to bore you with everything up there because I don't understand what all that does. You haven't. So we need to close this. It's very important. Once you save the library to Pico, close the script tab, pressing the X on it. Okay, so we've done that. You see, you also see a save library in your files sidebar now. So there we go, got that. As pointed out above, to open the new file ready for today's example, select a new by doing that. Using the DHT20 library and dictionary. A particular library creates a dictionary of stored values from the sensor for us to use in our code, but what is a dictionary in MicroPython? We covered list previously, which is handy for sorting data and variables and allowing us to quickly referencing them using the list index as and when we need to use it. Dictionaries are also used to store information, and they also allow us to retrieve that information quickly, but then we can be more useful when handling lots of data as each value is paired with a name key rather than an index number. Confusing? You bet. Let's go off on a complete tangent and make it clearer with an example. Okay. Imagine you're keeping a record of every Christmas song we like. Our records for each track might include the title, the artist, supporting artist, album, year, label, and rating. The sort of information you would stick into an MP3, I believe. Right, we will make the list for this data. The format would lay out like this. Blah, 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 blah. And the working example would be, I wish it to be a Merry Christmas, Wizard, 1973, Warner Brothers, I'm not going to assume that says, but can't read it because it's a copy over the top. That works, but it's going to be tricky remembering which index in the list is related to which field, and longer lists would be even more manageable. A dictionary might be a better option and will look like this. Title, blah, blah, blah. Artist, blah, blah, blah. And it is Warner Brothers, right? Rating number 5. Dictionary key equal handy. Where in the dictionary really shows its power compared to the list is when you want to grab data from it. You can use the name key instead and a random index number that you're never going to remember. Using our example above, let's print the release year of our song. First using a list. Song 1, 4. Now the dictionary, print song. Yeah, see the dictionary. Oh, we're supposed to have done that, are we? So yeah, that would work that way. Activity simple sensor reading test. Now that we understand the dictionaries in MicroPython, let's start simple run code and grab readings from the sensor dictionary every 5 seconds and print these to Thonny. Double check you did close the library file tab down. Did you close? No. Double check. Did you close the library file tab down? Yes, we did. We know we started a new one. If not, please do it. So, if you still got a load of text here, press the X up here, and then press that one to start a new page. Right. The code to use our library, we need to import it. So we use from the DHT20 import DH20 to do that. Our code then sets the ICT pins using, which isn't a lot of difference from how we use the GPIO pins previously. However, we need a couple of lines setting up I2C and our I2C device, the sensor. Every I2C device has an address. Our sensor uses 0x38. You don't really need to worry about this just now, but try to remember that if you ever want to run more than one I2C device in the future, you may need to check that the device doesn't have the same address. While loop then grabs the data from the sensor by bringing the dictionary and using measurements equals the ht20.measurements. Now we can access that data. We then proceed to print each value from the dictionary by using the name key and each available item. Here's a list of the data available in the dictionary, then from the library GitHub page. So the temperature, the raw temperature value is produced by the sensor, the relative humidity, the raw humidity values, and the result check the redundancy check for true or false. Fair enough. Run the code below and grab your first readings. This is where we find out maybe I should have stuck the heating on and not be so embarrassed how cold my house is. Press play. I'll run it. So it reckons it's 22.8 degrees in here. That's not so bad actually. Slightly above room temperature. I wouldn't be surprised it is actually kind of that because the radiator is just on that wall. Seriously, I could reach out and burn my fingers on it if I wanted to. So there we go. The humidity though. That was the humidity, wasn't it? That one there, yep. Oh, the one above it. 1 degree, yeah, this one. I have no idea what that. I know it's got a reading, but I don't know if that's good, bad, or indifferent. 51. Does that mean it's going to rain in here? I don't know. Anyway, press stop. But yeah, that's easy enough code. Like before with the GPIO ones, we need to set it all up and make sure we're using the correct things. That's kind of like, I know that's hexadecimal, as in I'm not going to make things confusing on them to bring us up to speed as well, but I know that's hexadecimal and that's the address. So that's basically sort of like, hey, you device, wake up. I'm talking to you, sort of thing. Right, readable readings. Now that we know what to grab the data from the library, let's format the data and add some other text to make it more useful and readable. We'll add strings to our print statements. And the central values in the round function, because obviously we don't need point blah 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 blah. And then it's talking about, we won't include the CRC underscore OK or the CLEAK redundancy check line, as we don't want to check for errors in our simple example. Basically, so it's simple, true, false value to see if the data has gone whoopsies. Right, we're going to introduce the formatted string literals to make our print even fancier than before. So let's cover that quickly. What are formatted string literals? A lot of talking today, isn't there? Formatted string literals is a simple term, allows you to mix strings with Python variables and a manipulation of their variables. And this all joins up at the end to make one very useful string. Great for print lines. But you already showed us how to add text next to a variable. We hear you cry. Yes, we did. However, formatted string literals are more powerful, as we're about to show you. So you want to print a line of like temperature, colon, 56.1 degrees Celsius. That doesn't seem complicated until you realize what the code needs to do to achieve that. It would need to start the string of temperature, grab the temperature reading from the dictionary, round the reading to 1 decimal place, inject a reading variable into that string, add degrees Celsius to the end. Here's the line of code that can achieve that using formatted string literals. So F, what does the F do? What does the F do? We'll find out later. But anyway, temperature, round, measurements, T and stuff I want. So wow, that's a lot of messing around. Alright, let's break it down a bit. Print F string literally need an F after the first bracket. Okay, but what is the F? It needs it, but what is it? Temperature, we start the string with a simple text inside the first inverted commas. Round, measurements, T1, any data we want to inject into our string must be inside the braces, the curly brackets. Inside the braces, we use the round function on the measurement temperature data, T, set in decimal places to 1. So that's what that 1 must mean. Degrees Celsius, we end the line with the degrees Celsius symbol and close the brackets and inverted commas. We also call them quotes over here. If that's a bit too busy for your liking, you can choose to round the data separately into a new variable beforehand. This causes an extra line of code but makes things a bit more readable. Yep, it does. Basically, you figure out what the temperature should be by rounding it and basically in the fancy calculation, but when it comes to printing it, you can read what, well, you know that that's going to be temperature. And also, instead of having to type this out again and again and again on different lines, to say that, you might want to say it was the temperature on Tuesday was blah, and the temperature on Friday was blah, if you were keeping a database. It would be easier just to do this and then print temperature. Anyway, the code, now that we've covered the formatting string literals, you should be able to see what's going on in the code example below. We've added some print lines using the formatted string literals for temperature and humidity, along with additional print lines for headings, blank spaces, and dividers to display our data clearly. We also add some large gaps in some of our strings to align everything nicely. Give it a try. Okay. So now that we know we can do this, I'm just going to close it. I don't need it. Start a new one. Copy, paste. As always, I recommend you type all this out, even though it's going to be a lot now. You know, keep your quite a bit there to be typing out. But let's press run. And there we go. It looks pretty now, doesn't it? At environment. The temperature, it reckons it's gone up to 23.1. I don't think so. The heating just kicked in. Humidity, 51.2%. Dear me. Is it really 51 point? Should be raining in here, shouldn't it? Right. Oh, is that 100%? Activity number 3. Let's bring the LED ring back into the project and use that to show what temperatures is on a scale. Find your ambient temperature. The first thing you need to do is to get a rough idea of the ambient temperature in your room, as this will be a midpoint in your scale. Run the previous example and keep an eye on the temperature for a few minutes and make a note of where the temperature sits. I sat at 20 degrees Celsius. We'll come back to you in a moment. As I say, I'm not that far away from the radiator and I've got a feeling it kicked in. So, shall we call it, I don't know, let's just call it 21 degrees because 21 degrees is a nice room temperature. Mine's a little bit too warm at the moment. Probably should go turn the heating off. Right, so that we're going to create a simple variable for the temperature reading using temp equals round measurements T Notice we don't use a number at the end to specify the decimal places. That's because we only want to deal with round numbers, integers. This variable will drive our LED ring. Our ring has 12 LEDs, so we'll create a temperature dictionary with 12 keys for each LED on our ring, placing our ambient temperature in position 6 at the top of the ring. Here's an example of using our ambient temperature at 20 degrees. So, yep, that's the way it would look. Working from this example in the above table, world temperature is 40 degrees Celsius. The first LED will be index 0, will be lit. When the temperature is at 23, the 10th one will be lit. Now grab a pen and make your own scale based on the average temperature. Start by entering your ambient temperature next to index 6, then fill the rest of the table. Okay. For the sake of time though, I'm just going to use their scale. I'm not going to mess around. The example below brings our next pixel library of associated little lines back in. When we then create a temperature dictionary, which try again with that. We will then create a temperature dictionary which we're going to use to convert temperatures into LED index values. There are other ways to do this, but we figure some dictionary practice makes sense today. It does, but I'm just trying to get through this as it is. Our while loop grabs the temperature data. We round this to a whole number of new variables called temperature. Then we start if the statement checks temperatures not in our dictionary 14 to 25. If we don't do this, when the temperature goes so high or low, it takes our LED index outside the possible range of LED ring, the program will fall over, also known as crashing. Basically, so it'll print out of range. If the temperature is within our dictionary range, the else statement will trigger instead. We then say take that temperature value as a key and use it with our dictionary to find what LED index should be used for that temperature. This creates a new variable LED index with the index value of the dictionary. Okay, that makes sense. We fire out a few print lines to allow us to check data of the variables, temperature and the LED index. We then clear the LED quickly before processing to light the LED that matches the index, just to make sure everything is already turned off. For here, and then we actually display the one that we're doing. Through full program, that was a lot to take in, so suggest running a few examples below, watching it work and having a few additional reads through the script and descriptions above. Try opening a window or gently blowing an air dryer over the sensor from at least 45 centimeters away. How far is 45 centimeters away in inches? Alexa, what's 45 centimeters in inches?
45 centimeters is about 17.7 inches. Did that answer your question?
Yes.
So, for your feedback.
You're welcome. So I'm sure I've just kicked off everyone's Alexa and it's all told you it's 17.7 inches. So don't throw your book at me. It's not my fault that you've got an Alexa near your computer with your speakers on. I could do a lot worse. Right. Let's copy this and press paste or run the script. And there we go. Because I'm actually currently at 23 degrees Celsius, so that'd be 20, 21, 22, 23. That makes sense. So it's getting a bit on the toasty side. I'm definitely going to have to go turn the heating off after I've done this. But yeah, have a read through of that. It has got quite complicated now. But that's also very interesting now. It means that, oh, has it really got to 24 degrees Celsius in it? I really do need to go turn off the heating. The thing is, though, we're now creating things that interacts with the real world, and we don't have to be there to make sure it's doing something. So you could actually mess around, put this in some kind of sealed box, run it off of a battery maybe, and then stick it outside, and you could have quite a useless temperature gauge, let you know how warm or how cold it is outside. Or you could even have it that an alarm started kicking off when we get to the point of speakers. I'm assuming there's one in this wonderful box of things, but you know, we're getting there anyway. So we've gone from not knowing how to do stuff to quite simple things to it's getting quite complicated now. It really is getting quite complicated. But as it says, go over it backwards and forwards till you understand it. When you do it, don't just copy it, type it out so you get an idea of this is where things go within the program. Alright, so day 9 is complete. We'll end the day there today, probably exhausted with your brain's final activities. They're not wrong. There you have it now. You keep an eye on your internal environment when the snow starts to fall and see how humid different rooms get when you close the windows and hangouts. You're going to have a very long USB cable go to different rooms, aren't you? It'd be kind of nice if it had a separate battery pack so that you could take it into a different room. Anyway, we ran some examples of LED ring, but there are lots of ways you can use it. Growing stash of components with these sensors. You could use the bar graph, you could use the blocky LEDs, you could change the RGB LED colors, use it with something. Oh, use it with something in one of the future boxes. Shh! I hope I haven't ruined anything with the speakers, because I'm guessing I literally haven't looked to see what's in all of it. I know you maybe, oh yeah, sure he has. I haven't. I like getting things like this, and I like it keeping a surprise. It's called being mature. You know, at least try to be anyway. So to recap, wiring a temperature sensor, what an I2C is and how they work, SDAs, the SCLs, the I2 pins and the Pico, installing libraries, using and creating a dictionary, dictionaries versus lists, and formatting string literals. Keep everything as it is until the morning, where we'll unwrap the next blinky component. See you then. Oh, that's good. Right, so I'm just going to stop this program, because of course it's still going. Oh, like I always say, if you got a bit stuck, have a look in the description for the Discord links. Come say hello, ask a few questions, or leave comments in the comments. Where else would you leave them? Don't forget to check out the links for the Patreon. Hit that like button, hit that subscribe button, and please hit that notification bell. But as always, happy gaming.